Hey everyone, today we are doing the page 3 of the 8.5 notes. If you haven't noticed, I kind of took out, right, I'm not using the original note sheet. It got a little crowded and a little too many examples, so I figured this would be easier to write it out on a note like this. To begin, we're just going to see if these two statements are equivalent. Is log of 24 divided by log of 6 equal log of 24 over 6? So essentially what they did is they pulled this out and left the log out front. Well, let's figure out if they're the same. To do this, you're going to need your calculator, so gg.gg/logancalc. It's linked. I've mentioned it a million times. I hope you know where it is by now. So the law you hit, for the first one, we're going to hit log of 24. Hit equals, you should get 1.38 divided by what's log of 6 now, log of 6. The log button is all the way to the right, 3 buttons down. Log of 6 is 0.77. So now clear this out and just do 1.38 divided by 0.77. 1.38 divided by 0.77. Should get 1.79. 1.79. Okay, so for this one, what we really need to do is just say, hey, what's 24 divided by 6? Well, this is log of 24 divided by 6 is 4. So let's see what the log of 4 is. Clear it out. Log of 4, and we get 0.6. So are these even? No, they're equal, excuse me. No, they're not equal. So we can't just pull out a log and divide them. That's what I just showed you. Okay, next up. I want to evaluate these two problems. We have 1 and 2. Remember, this is log base 5 of 125. I'm going to move this over because if it's not equal to something, we say it equals x. Then we write it as left to the right power equals the middle. So 5 to the x power equals the middle. And we should get it equal to 5 to the third. So the answer is 3. That one we knew because 125 is on our perfects card, right? Now, number 2, if we rewrote this in exponential form, we get 5 to the x power equals 162. What the heck is that? 162 is in our perfects card. It's going to be 3 point something, but how the heck are we supposed to figure out what that weird decimal number is going to be? That's what I'm teaching you today. Okay, when there are logs we don't know from our perfects card, for example, this or this, we use something called the change of base formula. You are going to need a calculator for this. Again, if you don't have it open by now, what are you doing with your life? But you should open this up. Please get your calculator out. Okay, so the change of base formula is log base b of x equals log base a of x over log base a of b. So if you notice in the original, there's nothing about an a in there. There's just a b and an x. Another thing I want you to notice is, this is how I remembered it when I was growing up. The x is higher, so it goes on top. The b is lower, so it goes on bottom. So if we wrote this like an imaginary fraction, when we do the change of base formula, x is on top, b is on bottom. But I do want to kind of talk about where does this a come from? Well, we are changing the base. We are adding in some base that isn't in the original problem. So, again, like I said, there is no letter a in there. There's only a b and an x. So, why can't we can pick any number for that a? So why not pick one that's really easy, like 10? And why would we pick a base 10? Remember, log base 10 on our calculator is just log. So if we pick a base of 10, we pick 10 because then our calculator does the work for us. Okay, so again, I picked 10 here because here's our change of base formula. Log base b of x equals log of x over log of b. Really, there are 10s right there, but again, we don't write the 10 because that's just, when we write log, the 10 is implied there. Okay, so a few examples. So just to kind of write this out, it says evaluate. So that means our final answer should be a number. So this problem is saying log base 6 of 41. Again, we add an x in there. So 6 to what power is 41? I don't know. I know it should be probably a little higher than 2 because 6 squared is 36. So 6 to some power is going to be 41. I would guess it's going to be like going to be about 2.1. But I don't know. Because 6 squared is 36, 41 is only a little bit higher. But I'm not sure what it is. So let's figure it out. And again, to do this, we're going to use the change of base formula. Okay, so here we go. To the change of base formula, we're going to say log of the bigger number, log of 41 over log of 6. Okay, when we type this into our calculator, one second, it closed out on me. What you can do is you can type it in just like this. I'll type out the buttons for you to press. You can press log. You hit 41. You close the parenthesis. And then you hit divided by log 6. Okay, I'll do it with you. Log 4, 1. Close the parenthesis. Divided by log 6. And you should get 2.07. And that makes sense because log base 6 of 41 is 2.07. So 6 to the 2.07 power equals 41. In the beginning, I said, hey, it's probably going to be around 2.1 because it's a little more than 36, and 6 squared is 36. Okay, I want you guys to try the next one. Again, we're looking for 4 to what power equals 91. Use the change of base formula, see if you can figure out what you get. Okay, so you should be typing in log of 91 over log of 4. And remember, this is technically base 10 and base 10, but you don't need to put that in because it is implied. So when you type this in, you should get log of 91 parenthesis divided by log of 4. And you get 3.25. So now if we did 4 to the 3.25 power. Where the heck did I do that? Is there a caret on here? I don't even see a caret on this calculator. Oh, x to the y right there. 4 to the 3.25. So now, what I was just doing to kind of just show you that this works, if you type in 4 on that calculator, and then if you type in the x to the y button, it is in the first column, third one down. You get an exponent. You can type in 3.25 into the little box that shows up on the calculator. And you should get let me see again, 90.25. We get 90.5 when we do this. So how come this number doesn't equal this? Well, it's really, really close, and we rounded 3.25. If we put in the actual value, we would get the answer. But for now, just round it to 2 decimals. That works for me. Okay, did I skip one of these? Oh, I skipped example 2. Look at that. So let's go back a little bit. My bad. Whoops. Boom. Boom. Okay, example 2, if you haven't already, you can try that. It's the same concept. Shouldn't be too hard. We're looking for 7 to what power equals 2. So to do the change of base, we're going to say, hey, let's put it in an imaginary fraction bar right here. Log of 2 over log of 7. Type that in to your calculadora. Log of 2 divided by log of 7. And you should get 0.36 if we're rounding up, 0.36. Okay, on to the last one. This one's a little bit different. It says log of 10. So we can think about this one of two ways. Well, you can say, well, change of base formula. There's a 10 right here. I can just do log of 10 over log of 10. Type that into your calculator. Log of 10 divided by log of 10. And you should get, well, let's type it in and see what we get. Log of 10, close your parenthesis, divided by log of 10. And you should get 1. Well, yeah, let's think about this from a logical standpoint now. Okay, what is my original problem really asking? Remember, that 10 is implied, the black 10 right here. This 10 is implied, and it equals x. So 10 to the x power equals 10. 10 to what power is 10? X equals 1. That's it. Okay, I hope today was a little easier for you. I have a few homework problems, and